and its impact on manufacturing and academia. Before we begin, let me take a moment to introduce our esteemed institution. Ashokrao Mane Group of Institutions, AMGOI, Kolhapur, established in 2009 under the visionary leadership of Sri Balasaheb Mane Shikshan Prasarak Mandal. It is committed to delivering quality technical and management education, especially to the rural youth of the Western Maharashtra. Spread over a lush 7-acre green campus along the Pune-Bangalore highway, our institute has grown into a reputed hub of academic excellence. The institute is AICTE approved, DTE authorized, affiliated to D-Batu for engineering and Shivaji University for the management studies, and has been accredited twice by NAC. And one proud announcement I would like to share with you all that from this academic year 2025-26, our institute has been granted the status of an autonomous institute. This autonomy empowers us with academic freedom to design and implement a curriculum that is in tune with latest industry requirements and global standards. The institute has received prestigious recognitions such as Best Engineering College in Western Region by ABP News and Best Emerging Institute by ISTE, New Delhi, with over 35 university rankers, 4 gold medalists, and 39 industry collaboration. Our institute continues its journey for preparing its students to excel the rapidly changing global landscape. It is under this spirit of innovation and excellence that we are now hosting the AICTE ATAL Faculty Development Program on Next Gen Manufacturing, Embracing Industry 4.0. So now, before we begin, I'm privileged to have with us today our distinguished dignitaries and resource person. I warmly welcome you all. I welcome our Honorable Campus Director, Professor P.B. Ghiwari sir. I welcome our Director, Honorable Dr. Mrs. S.R. Chaugule ma'am, respected Coordinator, Dr. Mrs. S.S. Patil ma'am, and respected Co-Coordinator, Dr. C.R. Dongasane sir. A warm welcome to all the esteemed speakers, respected faculty members, and all the participants who are joining us online today. With this, we proceed to the inaugural function of our FDP. For this, at this moment, I invite our respected coordinator, Dr. Mrs. S.S. Patil ma'am, to kindly address the gathering and declare the program is inaugurated. Over to you, ma'am.
Thank you, ma'am. So, good evening, one and all. Respected Campus Director, Professor P.B. Ghiwari sir, respected Director, Dr. S.R. Chaugule madam, esteemed resource persons, and my dear participants. On behalf of the organizing team, I extend a warm and heartfelt welcome to each one of you for this AICTE online ATAL Faculty Development Program. We are delighted to host such a diverse group of faculty members representing various disciplines, including computer science engineering, artificial intelligence, then mechanical engineering, electrical, electronics engineering from institutions across India. This FDP has been carefully designed to serve as a platform for learning, collaboration, and transformation. In an era driven by rapid technological advancements and evolving educational practices, programs like this are very essential to help us upgrade our knowledge, sharpen our skills, and innovate in our teaching methodologies. Over the coming days, you will have opportunity to interact with eminent experts, explore emerging technologies, and gain practical insights that can applied directly in your classrooms, research labs, and projects. So the sessions will not only focus on advanced techniques, but will also provide you with the tools to inspire your students as well as enhance the academic quality in your respective institutions. I encourage you to actively engage, ask questions, share your experiences, and contribute to discussions. Remember, the true value of such programs lies in the exchange of ideas and collaborative spirit they foster. I would like to take this moment to express our sincere gratitude to the AICTE as well as AI ATAL Academy for their continuous support in making such initiatives possible. To our respected director for constant guidance, to our entire organizing team for their dedicated efforts in planning this program. With this, I once again welcome you all for this online ATAL FDP and look forward to a week of productive learning, meaningful interactions, and inspiring takeaways. So thank you very much and best wishes for a fruitful program ahead. Thank you. Over to you, ma'am.
Thank you so much, ma'am, for your inspiring words and for declaring this program open. Now, it's my honor to invite our respected director, Dr. Mrs. Isar Chogule, ma'am, to deliver her introductory speech and share her valuable thoughts with us. Over to you, ma'am. Ma'am, kindly please, the microphone is muted, ma'am.
Yeah. Good evening to all the esteemed participants, respected resource persons, and my dear colleagues. It gives me a great pleasure to welcome you to this AICT online ATAL FDP program. We are joined by participants from across India, each of you representing wealth of knowledge, experience, and passion for teaching and research. This gives This FDP is designed as a platform for transformation in today's rapidly changing landscape, where artificial intelligence, automation, and data driven technology are reshaping industries. Our responsibility as an educator is a greater than ever. We are not only teachers, we are mentors, innovators, and enablers of change. Over the next few days, you will be part of interactive session, hands-on insights and experts interaction that aim to sharpen your skills and problems or broaden your perspectives. I encourage you to actively participate, ask questions, share your expertise, and build lasting collaboration. I sincerely thank AICT and Atal Academy for their continuous support in fostering such initiative and express my gratitude to our organizing team and resource persons for their dedicated efforts. Let this program not just add to your credential, but also spark a new vision for your teaching, research, and professional journey. All around 250 above participants from all over India, they enroll their name for this FDP. It will give more for coming week and you take the benefit by heart, be present by heart and get the knowledge accordingly. So once again, wishing you all enriching and inspiring experience. Thank you very much. Thank you.
Thank you, ma'am, for your motivating words and guiding us with your vision for this FDP. Having begun on such a positive note, let us now move to our first expert session for day 1. Our first resource person is Dr. Suresh Vikili, Associate Professor, Department of Electrical and Electronics Engineering, NIT Goa. He has completed his MTech and PhD from NIT Rourkela. His research spans smart electric grids, electric vehicles, PV systems, power quality, and wireless power transfer. Dr. Mikili has authored 2 books, CRC Press, contributed to AICT publications, and published 135 plus papers with 2,900 citations. He has guided PhD scholars and led funded projects exceeding 1 crore and delivered 125 plus keynotes and talks across India. Along with holding key administrative roles at NIT Goa, his profile is very vast. We are indeed privileged to have him with us today. Sir, we are eager to listen to you and I kindly request you to start this session.
Hello.
Hello. Yes, sir.
Uh, Hello, Ranjani madam. So,
Yes.
our first resource person will join within 5 minutes. So, before
Okay.
that, I just formally give the vote of thanks for the inaugural ceremony.
Okay, sir.
Okay, so good evening, all. Respected campus director, esteemed resource persons, and dear participants. It is my privilege to deliver a vote of thanks of today's inaugural ceremony. First and foremost, I express our heartfelt gratitude to the AICTE and ATAL Academy for their unwavering support and for providing us with this wonderful platform to share knowledge and experiences. Our sincere thanks to our respected director for the continuous guidance and encouragement which made this program possible and meaningful. I also extend my deep appreciation to all eminent resource persons. A special word of thanks to the participants who joined us from the various institutions across India. Your enthusiastic participation throughout provoking questions and active involvement made this program successful and interactive. Behind the scenes, our organizing team members have worked tirelessly for the smooth coordination and seamless execution. Thank you all. As we conclude, I hope that the knowledge and experiences we will get through these sessions in this classroom, research, and future projects, creating a ripple effect of innovation and excellence. Once again, on behalf of entire organizing committee, I sincerely thank for participating in this FDP. Wishing you all continued success and looking forward for the future collaborations also. Thank you.
Thank you, sir. I hope sir has joined. Will you
Uh,
please check once, sir?
yes, yes, ma'am.
I request all the participants to kindly hold on for 5 minutes as our speaker will be available in 5 minutes. So I request you to please keep patience and please keep your microphones muted. Once again, I welcome our first resource person, Dr. Suresh Mikeli, sir, Associate Professor, Department of Electrical and Electronics Engineering, NIT Goa. He completed his MTech and PhD from NIT Rourkela. His research spans smart electric grids, electric vehicles, PV systems, power quality, and wireless power transfer. Dr. Mikili has authored 2 books, CRC Press contributed to AICTE publications and published 135 plus papers with 2,900 citations. He has guided PhD scholars and led funded projects exceeding 1 crore and delivered 125 plus keynotes and talks across India. Along with the holding key administrative roles at NIT Goa, we are indeed privileged to have him with us today. Sir, we are eager to listen you and I kindly request you to start the session.
Yeah, thank you, madam. Thank you for the nice this one biodata. So, am I audible?
Yes,
I
sir.
will
You
share
are
the
audible.
interactive. Yes.
Yes, sir. Yes, sir.
Yes, sir. You are audible, sir.
So I'm sharing the screen. Is it visible?
Yes, it is
Yes, sir.
visible, sir.
Visible.
Yes, thank you. Good evening, one and all.
Good evening.
First and foremost, I'd like to thank the organizing committee of Ashok Ramanek Group of Institutes World. So for inviting me for this first day session of ATAL FDP, 6 days online FDP on next generation manufacturing, embracing industry 4.0. So now I'm going to take the first session and ninth session also. So in this particular session, what I'm going to take is what is the process of innovation development. First, I will concentrate on process of innovation development. Then TRL levels, that is technology readiness level. So we are having different TRL levels are there that I'm going to concentrate. Once that is done, if time permits, I will try to explain you commercialization of lab technologies and tech transfer, how to do. So how to take it to commercialization level. Is it clear? So today's session, we are going to see process of innovation development. So how to generate the idea. Okay. So from development to till commercialization. This is what the topic today. Fine. So I want a little bit active participation. So it will be the foundation for next remaining sessions. Fine. Okay. So first of all, let me tell you brief about. So ideation means you should understand. Ideation is composition of different ideas or concepts. Everyone knows. Okay. So ideation is nothing but it is a composition of different concepts. Okay. So then what we label, why we are calling as ideation, reason is it can also be interpreted as a spark of light revealing the new course of action. Okay. Ideation in the sense we are providing or revealing the new course of action what we are taking. Okay. So let me tell you. See, the fresh ideas are the main heart of innovation and advancement. So generally, when you consider rather than continuing, there are two ways are there when you're doing the research work. Either continuing to the existing work, add the delta X, and do the improvement, or else innovatively fresh ideas can be generated. Okay. So when you call fresh ideas, these are the heart of innovation and advancement. These are published in IPR. So the patents mainly that comes from the fresh ideas. Okay. Suppose if you are keep on continuously depending on earlier project and only you are doing delta X, then you are basically dead. You are not doing proper research. So after certain amount of time, what we need to do, you have to create the fresh ideas. Okay. You have to do the innovation and advancements in the area which you are working. Okay. Without them, you are dead, I can say. Okay. Now, there is one saying, only an idea. Okay. Okay. With this brief introduction, let me start. There are 3 steps are there for the to product the ideation. Mainly, there are 3 steps to product the ideation. What is that? Generation of the idea, selection of the idea, implementation. Is it clear? So one is, there are 3 steps in the production ideation. Ideation consists of generation, selection, and implementation. We will see each part, okay, the process. When it comes to the generation, okay. So generation means you are determining or the criteria to evaluate what type of ideas are generated. See, everyone will say like, this is the new idea got generated, or this is, maybe you will have a different type of like ideas, or maybe different type of concepts can be there. Okay, so but if you want to generate a generation of ideas, need to be validated properly. Then after that, implementation is very, very important. So we need to, when you do generation and selection, actual implementation, when you're doing, these topics has to be addressed throughout the following steps, which includes, we need to determining the criteria to be used to evaluate the ideas generated. What does it mean? Suppose you are having 10 ideas are there. Okay, we need to, the 10 ideas, if I want to go for implementation, okay, is it feasible or not? Some criteria has to be set. What is that criteria? We need to define the proper reviewing system. Suppose you are having 10 ideas are there, 10 can't be implemented in the hardware. 10 ideas can't be commercialized. If you are having 10 ideas, the 10 ideas can't be implemented. All 10 ideas may not be commercialized. Only when all the ideas are extremely good, then only implementation and commercialization may go. If ideas are, a few ideas can be implemented and commercialized. So for that one, we need to strongly, first we need to review them. Okay, then we need to understand process of handing over the finest ideas to the respective teams. Okay, once you are having certain ideas, first you need to review them thoroughly. After that, we need to hand over those ideas to the respective groups for executing them. Or else, if the idea is not proper, and if the reviewing team says some corrections are required, at this moment you need to defer. Or else, if the idea is extremely good, then you need to give to the finest team for execution. Is it clear? So the assigning ideas to the respective people, there is a process is there, and prioritization is there. Okay, so when you consider idea generation sourcing, from where we can generate the ideas, first of all, generation, selection, implementation is there. Generating ideas, reviewing process also thoroughly has to be done. And after doing the thorough reviewing, then we need to hand over to the finest groups. Finest ideas need to be given to the respective groups for executing it. Okay. Now, what is the source of idea generation? From where the ideas can be generated? There are 2 main groups will be there. Idea generation, 2 sources are there. One is internal sources, second one is external sources. Is it clear? To generate the idea, we are having 2 sources. One is internal source, second one is external source. What is the internal source? Our own R&D will be there. Our own internal employees from various departments will be there, or customer service will be there. own R&D in the sense, suppose your institute itself, R&D facilities might be there, their group of people might be working. Either PhD scholars or MTech students or BTech students who are working on the particular concepts. You have your own research and there are some universities will have your own R&D. From their ideas can be generated. Okay, while generating the ideas from the own R&D group, ideas can be generated, or else second one is from the internal employees from various departments. Now you are working with one department. Suppose today electrical department or maybe mechanical department is there sometimes, and we are having CSE, EC departments are there. Suppose you are working on electric vehicle. Electric vehicle involves what? Even mechanical engineers also can work with the electrical vehicle concepts. Even there are cybersecurity issues will be there. There are battery management issues are there. So what I mean to say is nowadays there is in every projects people are working. So you need to generate the idea in such a way that the idea should be sustainable. So when you consider idea to be sustainable, you have to take the input from internal employees of from various departments you have to include. Now, at present, earlier, only individual departments, if you work, that was sufficient. But now, it is mandatory to have a nice a group of people. Our networking is very, very important to do the best research. So the internal source of idea generation is not only your own R&D, your own department or own cells, even you can have the internal employees from various maybe external departments also can be taken. And third one is the customer service department. Okay, so with whom you are working, sometimes what will happen, you may take consultancy projects. Through the consultancy projects has to be done. Suppose when you're taking the consultancy project, even your customer service, how it is, what they need, what is the requirement, based on that one, so how to do, what to be implemented, what algorithm has to be done, what controller need to be added. So you should have your own customer service department, so whom you are addressing. Fine. One is internal sources is idea generation, own R&D will be there. You can have internal employees from various departments can be involved and ideas can be generated by discussing and by considering interdisciplinary concepts. Not only that, on which concept you are working, you can work with the industry and we can work with the customer service department. This is internal sources. What about external sources? External sources are meant for the customers. Okay, as I told you, these two are interlinked. As I told you, external sources are which industry you are targeting, or which academic organization, and which concept you are working. So your customers are the prime source of your generation, or which industry you are targeting, or which concept you are targeting. So the customers, is they really satisfied or not in the idea? So the generation of idea can be from the customers or from the fellow researchers. Competitors are, when you consider a research, your fellow researchers, other people, how they are working. Fellow competitors in the sense, fellow researchers, how they are working in this area, what work is going on, what methodologies are implemented, what controllers are implemented, what algorithms are there, or which methodology they have considered, which new tools they have considered. Okay, what type of the innovation is there in their paper. So we need to understand and we need to see in that particular area who are the competitors, how they are excelling, what they are generating. So how I change my concept or how to improve this technology. So you have to see. Is it clear? So when you consider, we are having two sources, internal sources, external sources, the idea can be generated. Now, as I told you, idea generation is sources from, can be get inspired from the new product features, okay, as internal and external. These are already I have discussed. Okay. Now, here I will say clearly that the customers we are talking, no, the customers. Now, there was one saying is there. What is that? If you consider internal people, no problem. We are mainly talking with your own R&D people as well as internal employees from other departments. Okay. So your engineering team, your IT team, your service team, with all the people you are doing. So no issues at all. But when it comes to external sources, the first and foremost is your customers. Bill Gates once he said, what he said, your most unhappy customers are your greatest source of learning. What does it mean? Suppose you submit your paper to any of the IEEE transaction. Let us suppose if you submit your paper to any of your IEEE transaction, if your paper is accepted, you will not learn anything. If your paper is rejected by 2-3 transactions, you will understand that many critical reviews you will get, that many ways you can do better. Am I clear? Suppose you are working on any of the concepts you have submitted your paper to some good transaction paper IEEE or maybe Web of Science elsewhere, good SCA journal you have submitted. But when you submit to good IEEE transaction or SCA journal, if you get 2 or 3 rejections, you will understand that through 2 or 3 rejections are reviewed by there are different people or different experts. So what happened? You will get that critical reviews. When you get the critical reviews, those are the greatest source of learning. Why? You will understand that many ways. If you take it in a positive manner, that many ways we can improve our paper and the quality of your work will be improved. Or else, the first attempt, if your paper got accepted, if you go with normal Scopus journal, normal low rated journals, paid journal, if you go, if you can't grow or you can't achieve the transaction level. What I mean to say is, don't be happy with the smaller ones. You try target highest one. Let the rejection. Sir, am I audible now? Am I audible now?
Yes, sir, you are audible. Yes, sir.
But someone is telling like my voice is breaking. Okay. Is it okay now?
Yes, it is having a little bit network issues, but now it's okay.
Now it's okay, no? Okay, sorry. Okay, when you
Yes, sir.
are idea, when you are generating, now it is okay, no? So there are two ways are there for generation of ideas.
No, it's not okay,
Okay.
sir.
So
There
one
is
is internal
too much
sources.
network
Second one
issues.
is my side.
Yes, sir, we are not getting properly.
Now, am I audible?
Yes, sir, now it is.
Madam, am I audible?
Yes, sir, you are audible, sir.
Sorry. First one you okay. No, okay. Sorry. Okay. So when I have started, no, I have started about ideation. There are three steps are there: generation, selection, implementation. Okay. So when you comes under generation, what I have told, so we need to determine the idea properly. Okay. And you have to review that idea, whatever generated idea, and we need to process that idea. Okay. For handing over to the finest ideas. Okay. So here what I have told is, when you generate an idea, n number of ideas can be generated. All the ideas can't be commercialized. Few ideas can be at the level of simulation. Few ideas can be at the level design it will reach. Few ideas can be reached up to the product oriented, but few ideas only can be commercialized. Is it okay? Now, I have told you two types of sources are there. One is internal sources. Second one is external sources. So the internal source is your own R&D, okay, and your internal employees from various departments, and you can take various departments in the sense nowadays we are having interdisciplinary projects are there, isn't it? So the people are considering, even electrical person is considering smart electric grid. You take cyber security issues in smart electric grid and cyber attacks in smart electric grid, these are well taken. So only electrical engineer alone can't work on that. So we need some expert from the AML or computer science. So mutually the people will work. Suppose if you take a concept of electric vehicles, so sometimes battery management system is there. Alone electrical engineer may not completely design the inside charging infrastructure. So we need to have the skilled person from mechanical engineer also. So nowadays, so the internal sources for idea generation will be internal employees from various departments can be taken. Is it okay? One is your own R&D. Second one is, so internal sources can be taken. Is it okay? This much you understand? Next, we are having external sources are there. So that is the customers and the competitors. When you call the customers, so which area you are targeting, what improvements you are doing. So that is the prime thing. And second thing is your fellow researchers will be your competitors, like how others are working, in which area they are working, what algorithms they are implementing. Okay, so what type of control flowcharts they are considering, what type of controllers they are considering, which methodology they are using. So the everything is very, very important, how others are working, other competitors. So you can generate the idea from the customers as well as from the competitors. This is what I told. So now I told you one more thing. So your most unhappy customers will be your greatest source of learning. Why? If you submit to any of the IEEE transaction, if you get a rejection, be happy for that. Why? You will get the more amount of critical reviews so that you can get the best out of it. If you address properly, you can get the paper will become a better manner. It will be flawless. Otherwise, if you target on small journals, and what will happen? You may get one count, but it is very difficult to continue the topic. Is it okay? Now, let me show you several ideation techniques are there. Okay. So how to select? So there is the brainstorming, the focus groups, mind mapping, Scampo, storyboarding, reverse thinking, and sketching. Okay. So we are having 7 main selection techniques are there. Okay. Am I audible now? Is it okay?
Yes, sir.
Now,
Yes, sir.
what is meant by brainstorming? What is meant by brainstorming? So if you want to select, as I told you already, very few concepts can be go to commercialization, TRL level. TRL 0 level to 9 level will be there. So if I want to go ahead with a commercialization level, initial step, the first step is brainstorming. What is meant by brainstorming? It is most popular and widely used method, okay, in solving the idea generation. Here objective is simple. What is that? You come up with all the ideas, imaginary ideas about a specific problem. They will tell you one particular concept. Okay, they will ask you, you come up with all imaginary ideas about a specific topic within the restricted time frame. So what will happen? So each and every one of the ideas are documented. So when they have given the time frame, within the time frame, you will come up with all the ideas, and what we will do, each and every one of the ideas will be documented. Okay. Now, what we will do, here we will not do any criticism. The evaluation session will be ongoing. So we will not say anything. We will take all the ideas. Now, what we will do? Now, this gives the space to the most of the even good, bad, all ideas will be taken. Okay. So then after that, what we will do? A good size of group of usually 6 to 10 people, okay, will be there to exchange further and to make the clusters to join the ideas together. Initially, on the particular concept, individually we are asking them to give particular ideas within a time frame. We will, all the ideas will be documented without banning a single idea. Then we will make the groups in such a way that, okay, we will try to see the equal-minded people or equal concepts or similar concepts can be combined together, and can be some of the 2-3 concepts can be combined also together. Okay, they will put or they will join the ideas together by making the clustering. Clustering is grouping of similar patterns, I can say, grouping of similar ideas. Okay, now, but here the difficult part is scheduling, organizing, and the practically implementation. That is one thing. So first, through the brainstorming, what we are doing, we are taking different ideas from different people within the time frame. Then after that, all the similar ideas will be segregated. Clustering you are doing. Okay, through the brainstorming session, 100 ideas you are taken, you are converting into maybe 5 groups or 10 groups. That way. Now, next, focus groups. What is focus groups? As the name prevails, this technique brings together a small group of individuals with divergent characteristics with the aim of providing a structured format. I told you already. So what is that? So here groups we are taking to create the productivity. So you are having internal sources people are there. What is that? Even from other department people also there. Now what you are taking is not exactly the same characteristics. So your group consists of divergent characteristic people you will take with the aim of providing structured format. What does it mean? If you consider a concept, any concept, that concept will have 2 or 3 different things are there. One will be good in controller. One person can be good in maybe system methodology. One is good in maybe hardware implementation. One is good in maybe cyber issues, other things. So you will try to consider group of divergent people, and you will keep the idea in the structured format. You will assign the things. Focused groups will be considered. Okay. So here we are going to do qualitative research, including interviews, the reactions, perceptions, all the things will be examined. This technique is useful in the early stages of ideation. Why? Making a concept stronger and incorporating the feedback. Okay, before you are going for actual development, you will keep the groups, you will understand the concept, you will keep it more stronger by considering the concepts. Now, next one is mind mapping. Okay, in the mind mapping is you will visualize, you will organize the information in a structured format through your brainstorming sessions. Okay, now here what we will do. Okay, so participants will start writing anything else comes to the mind, and once that is done, you will connect everything in the order. Okay, so through mind mapping, also through brainstorming can be done, through the groups can be done, selection through the mind mapping also can be done. Okay, add ideas later at any time, which will help link the ideas. Now, one more, the best method is scamper model. Scamper model is S means substitute, C means combine, adapt, modify, put to another use, eliminate, reverse. What does it mean? 7 steps to provoke the creative solution to challenging problem. What does it? Substitute. Suppose if any one particular concept you have taken, there what you are doing, suppose you have taken a particular system, there only you are concentrating on one concept, or only you are changing a controller, or you are changing a one particular block, maybe control algorithm. You might be changing the methodology. So you are replacing a only one part, you are substituting. Only you are working on, suppose you have taken grid connected system. We are having initially PV systems will be there, converters, inverters, MPPT will be there. Okay, then there is integration will be there. Now here any one concept will be taken from n number of stages. Only you are replacing one part. You are strictly working on substitute. You are doing replacing a particular part. That means your idea is only working on, suppose electric vehicle you take. Inside electric vehicle, converters will be there, inverter is there, motor drive is there, you're having a battery is there. So one person may be completely working on battery, one person will be completely working on motor drive, other person will be working on converter, other person will be working on inverter, so another person will be working on charging topology, other person is working on standards. So any one particular concept you will work, and you will replace your the best idea with the existing one. Understood? Substitute means replace existing idea with your new innovative idea. This is one way. General research people will do is new methods people will propose, new controllers people are proposing, new algorithms people are proposing, new methodology people will propose. Like new system itself you can propose, complete system, or in the system only one part, that is what? Only algorithm, only one controller, only one particular converter. So any one thing you are substituting, that is S, the basic one people will work. Second one, combine. What is combine? You are working on both converter and inverter. When you take in a converter, different rating is there. When you, the moment you work on the converter, inverter also is required. So sometimes 2 or 3 elements, if you change one element, substitute one element, there is another element will influence. So you need to join the elements ideas together to make the new base. Sometimes you can merge them. Understood? In one system, if you work on one algorithm and a controller, new controller with a new algorithm, or new converter and inverter systems, battery and charging topology. Suppose one battery I changed, how fast that material can be charged with which way. So when you consider one particular system, for that one, there is another joining element will be there. So you can merge two concepts, that is called combine. Third one, what is adapt? So modify something to better suit your new purpose or new prospect. You can adapt the system. Third one is similarly, fourth one is modify. You enlarge, reduce the change shape. Okay, modify the shape, alter the attributes. Okay, so what will happen now? Let us consider EV only. Some of the times you might have observed there is a blast on batteries or electric vehicles, or sometimes you might have observed the blast. Now what I need to do, I need to add small amount of coolant inside. Suppose they are using air cooler, you need to use dielectric material, or hot spots are there, I need to use how to reduce that. Am I getting or not? Suppose I need to use, you people might be using converters are there, silicon based converters you are using. Instead of silicon converters, now SiC based converters are there, silicon carbide converters are there. So now just your same converter, you might be use different material. A same converter can be modified with cascaded suppose after certain years of use, the converter or electric loses its electric properties. So what we will do in the cascading method, one more can be added. It can be enlarged or it can be reduced. It can be shape change. So you are doing the little modification. The first one is entirely you are replacing, substituting one element. Second one is you are combining two concepts and you are doing, you are adapting the better purpose. Third one, fourth one is just you are modifying little changes. After that, P is put to another use. Rather than changing the things itself, consider changing the content it exists in. Okay, so next, eliminate. What is eliminate? Remove the elements to simplify your system. Suppose there are unnecessary, some of the elements are there. Suppose rather than a single bidirectional converter is there, one converter itself will do the both the things. Like you are having a dual converter is there. Even instead of considering, rather than using a space converter and inverter, you use a dual converter which serves both the purpose. So you need to eliminate some elements. You need to replace, modify the system with, by eliminating with new one can be substituted. While eliminating, removing the system, or by eliminating some of the elements, what we need to do, it has to function. When it has to function, you are eliminating particular things, you are substituting with another thing. You are eliminating the particular thing and you are modifying in that. Last one is reverse. Reorder the priorities. You do it, you are eliminating it. What to be replaced? What to modify? What to adapt? Which to combine, which to replace. So reverse order. So when you consider idea generation, either you can substitute some algorithms, or you can replace things, or you can combine some technologies and you can modify the things. Okay, you can eliminate few things and replace with other way. Okay, so this is the scamper model. Generally people will consider. Now storyboarding, it is developed by normally listening. What is that? How product can develop, how it will look once I have designed particular thing, how it looks, storyboarding. Okay, this technique assists the creative people in representing the information, how the particular the converter looks like, or how this particular the system will looks like. Okay, so what stakeholders are expecting, how the product can evolve throughout the upcoming increments. So this is what storyboarding in the sense visualization of the your system. I told you reverse thinking. What is reverse thinking? So practicing the reverse thinking will help you. Like, okay, you should have a question and answers. Okay, you should not take it granted. Like, I will consider this technology, it will work out. If suppose if anything happens, out of the box question, what does it mean? If probably no, this technology won't work or this converter won't work. So how the problem is? Suppose there are heat sink properly not there. So what type of effort can be taken? You yourself, you have to be in the shoes of the customer and you have to think 1,000 times before releasing the product. Okay. Now, so now what I will do? How can I double my revenue? Can I transform into? How do I guarantee that I have no revenue at all? Sometimes you may think, how can I double my revenue? This is one way. How to transform? How can transform into maybe from 10 pieces to 1,000. This is positive thinking. Now reverse thinking is, how do I guarantee that I have no revenue at all? So you should think in a reverse manner. Okay. Now sketching. Remember that one small good picture is worth of 1,000 words. How your schematic diagram looks, how your product is visualizes, that matters a lot. Okay. So that's why your concept should be properly sketched. Our design should be proper. A good paper need to be accepted in the sense how much theory you're writing not a matter. How good your illustrations are matters. Okay. And in that illustration, you have to give the processed results. Suppose when you are giving any of the results, you should not give a print screen results. You have to give the processed results. What does it mean? In the result itself, you have to show, okay, this part is this is this. So you have to indicate each and everything. The person can, by seeing the diagram, he should understand, oh, these many components are there. Oh, these are connected this manner. These many sub blocks are there. So person should visualize the entire concept. Your diagram should be in such a way that the visualization should be proper. Okay. And the sketching should be proper. Okay. Now, to implement ideation, we are having 8 rules are there. So these are selecting the idea. When you are selecting the idea, so what we are having, so we are doing the brainstorming, we are doing selection of idea, brainstorming we are doing, focusing the groups, mind mapping, scamper, storyboarding, reverse thinking, sketching, these many things we are doing. But after that, when it goes to the implementation, what to do? We are having 6 rules for idea implementation. One is define the objective very well. Okay. Second one is be customer centric at all the times. Involve the right people and define some borders. Challenge all existing assumptions and successful execution. First one, when you define the problem properly. So what is your main objective? So what you are going to take the action, you have to define properly. Second one is always when you're defining something, how it will be useful. You should be in the shoes of the customer. You should be shoes of editor. You should be shoes of the particular other side. And always you should be the customer centric all the times when you're implementing the idea. So when you're doing implementing the idea, you have to involve the right people. What does it mean, right people? Good mix of people. I told you already, you have to involve different people from various departments in such a way that your work will be completed in a nice manner. If all are same level people, if you take, see, I told you already example, if you are designing a smart electric grid or anything, you need computer science people to take care of cybersecurity issues, information protocols, EC people will take care. There is integration of converters, inverters, electrical people are required. There are skilled people, unskilled people are required, and there are from different engineers are required. If you consider EV, batteries, converters, motors, so many are there. Both good mix of both the engineers related to material science is required, related to mechanical required, related to EC required. So your particular concept should involve right people, and there should be a good mix of people who has the vision more detail oriented. Okay. And you have to define some borders. You thinking is sky is the limit, but at the end of the day, you have to stick with your objective, isn't it? You have to stick to your objective, ensure what the customer is expecting, what is your objective. So you should have the proper borders. This is what my target, this is the task, Then after that, yes, you can extend. After that, yes, you can change the designs. Now, challenge all existing assumptions. Okay, the reverse and the successful execution can be done. So these are the main bases. So process of innovation development. Now, when you take, okay, so innovation development transforms idea into a marketable product or service through the structured stages, ensuring feasibility, scalability, market relevance. What does it mean? When you do process of innovation development, if I want to go for one innovation is there, you want to develop it, you want to convert idea into a product, you want to convert idea into a commercialization. So innovation development, it transforms idea into a marketable product. You are converting your idea into a product through structured stages. But what you should ensure, feasibility should be there, scalability should be there, market relevance should be there. Suppose if you are designing a particular product, it should be feasible. And second one is, it should be scalable. Scalable means now you are designing a particular concept or particular product. So if you're designing a particular product or concept, you should not restrict to only one design, two designs, 10 designs. You have to see what is the relevance in the market. If I consider this product, can I able to increase to 1,000? Suppose you are designing off-board chargers. Off-board charger in the sense, suppose future is going to be EV. Off-board charger in the sense, like same multi-port charging station I am designing. Let us suppose the charging station will have AC supply, DC. For two-wheeler can be charged, three-wheeler can be charged, four-wheeler can be charged. It itself it consists of AC charging, DC fast charging, ultra DC fast charging. So when I consider that all over India I can implement. If I design a particular product, is it scalable or not? Can it be feasible or not? Product I am designing, is it feasible to design? Is this particular concept, the future is scalable or not? Whatever I am designing, is it relevance in the market or not? For that, what I should do, I should understand what is available in the market. What is the drawback of existing system? What is the drawback of existing system, not only technical manner, commercialization manner, and the financial manner. Not only if your idea is technically sound, not sufficient, it should be technically sufficient, at the same time the financially feasible. Understood? It should be technically feasible to design and financially also feasible to design. Then only scalability will increase, and it should be relevance in the market. When I'm designing, relevant thing has to be taken. Okay. Now, when I want to design, there is a stages of innovation development is there. What is that? Idea generation and discovery, concept development and feasibility, prototype development. These are TRL levels. Validation and testing, scale up and manufacturing, market launch and commercialization. Try to understand. One idea is there. TRL level I'm going, like idea to innovation development. Innovation development means I'm going from idea to commercialization. See, idea generation to commercialization we are going. In this, these many steps are there. What is that? First, idea generation and discovery the new concept. Okay. Idea generation, selection. Second one is after selecting the concept development. What is concept development? You are 100 ideas through the brainstorming you have taken. Okay, through you find a groups, mind mapping you have done, scamper technique you have considered, reverse engineering you have done. After doing all the things, you have developed a one concept. After developing the proof of concept, is it feasible or not? How you know the feasibility? You will do the simulation studies. You are creating the idea, then selecting the idea. After selecting the idea, then you're doing the proof of concept is proper or not. That means you are doing the mathematical modeling here. Fundamental theory you are seeing, then selecting the idea, mathematical modeling, concept proof is correct or not, you are checking here. Okay. After doing mathematical modeling and design aspects of mathematical modeling, you are checking the simulations, you are checking the environmental issues, you are checking the boundaries, you are checking the feasibility of everything. After doing that one, you are going for prototype development. So now with scale down values, you're going for prototype development. After the prototype development, what you're doing? You are doing the validation. Is my simulation, is my theoretical results as per the concept, is my simulation results, is my prototype results, all are, am I getting same or not? Theoretically, you are getting something, proof of concept. Simulation wise, you are getting some results. And through the prototype, what you got? All theory, simulation, and prototype 3 need to be validated. How you validate? By using different testings. By using different testings, different conditions, and different boundaries has to be taken. And during different testing conditions, you need to validate your proof of concept with the simulation, with the hardware. And you need to see the how feasible your system from theoretically, mathematically, simulation wise, and prototype wise. Once you understand, yes, the concept is good. Initial prototype development is laboratory level. Initial development is like any student is there. Suppose research scholar is there. First, the person is idea will be created. After creating the idea, that means a number of ideas, you are selecting the idea. Then you are checking the proof of concept, theory, mathematical designing, modeling. Once it is done, we are going for simulation. Once it is done, laboratory level hardware in loop prototype we are doing. That is called validation at your laboratory level. Once laboratory level, you are okay with it. It has to be extended to real-time testing. What is that? In the real-time environment, is your system is feasible or not? You got my point? After idea generation, selecting the idea, you are checking the mathematical modeling, fundamental concepts you are checking, mathematical modeling you are checking, then you are checking not only mathematical modeling, you are checking the design aspects, the parameter values, then the design values are compared with simulations under different conditions. The simulations will be compared with prototype. Now, while validation, you are testing under different condition, theory, mathematical values, theoretical values, and simulation values. Your laboratory prototype values will be validated under different test condition. If you get everything proper, now what you will do? Again, you will go for feasibility study in the real world where you are implementing that concept. Laboratory level environment will be different. Real test conditions environment will be different. So when you take your methodology into the real place where you are installing, it should be feasible to not only internal test conditions, external environment conditions also, your system should be feasible. So after doing the prototype development at laboratory level, it will be extended to real world. Then if it passes both, proof of concept is good for simulation, laboratory, and real world, then you will go for scaling up. Then people will go for manufacturing. Not they will not go directly manufacturing. What will happen? Suppose you are designing charging topologies like charging infrastructure. We are having ARA, Okay, so we are having different associations are there, different standard bodies are there. So we need to take the permissions from those particular societies. Is my system is properly understood? No, is my system is meeting the standards or not? Is my systems or is my designs particular protocol it is following or not, that communication is properly doing or not, everything we need to check. As I told you, if it is EV systems, if you are designing, there is automatic research association. Now the government has initiated so many testing centers. Now you have to take certification from those bodies to do the manufacturing. If I want to go ahead, that ISO standards, people say no, you need to get certification from the authorities. Once you get a certification from for your concept, for your system, then you will go for market launch. Once the market launch, if you get a good results, more products are going, then you will go for commercialization, you will go more scale up. I hope you understand. These are the stages of innovation development, from idea generation to till commercialization. Okay, now, so key methods of idea generation, I told you already. Just brainstorming sessions, collaborative meetings, the cross-functional teams, market research you are doing, market research, identifying the main points, then technology scouting, exploring the emerging technologies in the adjacent fields you are seeing, then design thinking workshops like this. You're attending more workshops, you're learning, then you're doing, then competitive analysis. Okay, you will see the gaps, you will see the opportunities by analyzing competitors. Okay, now after brainstorming session, market survey you are doing, you are checking the emerging technologies, you are attending more workshops, you are checking the analysis of gaps and opportunities, then you are going engaging with external innovators. You can engage with startups, you can engage with academia. Understood? The key methods you need to do is this way: understanding the issues, understanding the what industry required, what market is required, understanding what technology they are using now, then know more about what is the technology, understand what other competitors are doing, then you yourself involve with networking with other innovators, startup companies, academia, then you go for idea generation. It is not so easy just one day just to create the idea, go for publication. So rigorous research study if you do, the rigorous market research if you do, if you understand what is existing, what is the gap, if you understand what others are doing, if you understand, then you can then generate 10 such type of solutions you can generate. Otherwise, if you won't understand the market survey, what happens? Think reverse. If you have not done just market survey, you don't understand what present technology is there. You are not understand. You have not attended any workshop. You don't know who is the competitor is. You are not involved with any of the external innovators. You are not involved with any startup or any academia. You alone you are doing. Can you able to give proper solution? But if you follow or if you do this process, you will have, instead of one paper, you can publish 10 papers. Why? You know what is the issue, where I should concentrate. You know what technology people are using. So if you follow this process, yes, it may take some time, but after that, you will excel in generating the ideas, in implementing the ideas. Okay. Now, so when you see the first one, idea generation and discovery. Okay. Idea generation discovery is identify opportunities through unmet needs, through technology gaps, or through the trends. I told you generation is brainstorming, R&D initiatives, customer feedback. Okay. Now, an example I will give you. Tesla identified need of high performance electric vehicles (EVs) when the market was dominated by gasoline cars. Isn't it? Tesla has identified we need high performance EVs when the market was dominated by IC engines. So he developed EVs. How he got? That is through the customer's feedback, through brainstorming session, through R&D initiatives, through the market survey, by engaging with innovators, by engaging with startups, by taking feedback from the people. Understood? It is not so easy to generate. So the Tesla has come up with high performance vehicles. Not only one day they have not come. They understood market survey. They understood what is the drawback. Now they come up with a survey. Then if you understand what is the problem, what solution I have to give, then the solution is ultimate. Okay. Now the concept of development and feasibility. Second one I told you here. What is the concept? First one is idea creation is understand the market, understand the existing technology, understand the existing modeling. Then you go for the need of what to meet. Next, the proof of concept. Concept of development is the proof of concept. It is called assess technical, financial, market viability. We need to see technically, is it sound or not your concept? Financially feasible or not? Market wise, the relevance is there or not? I told you already. You have to see your concept is technically sound or not, financially feasible or not, in the market relevance is there or not. So that's why you have to do SWOT analysis. What is that? What is the strength of your system? What is the weakness? What opportunity we are having? What are the threats? When you consider this concept, or when you consider this group of people, what is the strength of my group? What is the strength of my concept? What is the weakness of the concept, weakness of the group? What opportunity is there technically? What threats are there financially? Or what threats are there in the market? So I should understand the SWOT analysis properly when you're developing the proof of concept. And you have to see the feasibility studies and market survey again. Example is Dyson. Dyson has conducted extensive research before developing the bladeless fans. You might be knowing, no? They have developed bladeless fan concept. You Google it, we have the bladeless fan concept Dyson has given. Now, the prototype development. So when you go with the next one, prototype development, once the concept you understand and your design, the prototype development, you need to build the models to validate your concept, to validate your designs and functions. Okay. Example is Apple's iterative prototypes of the iPhone underwent multiple designs revisions before market release, isn't it? Prototype, when they're developing, they're validating the designs, they're doing the iterative process, they're underwent with multiple designs and revisions they will do, then people will release. So when you do prototype development, you should do reverse thinking. Is this work or not? Is this okay if I release? Is it technically feasible or not? Is it financially feasible or not? Market relevance people will consider or not? So everything has to be checked. Now, validation and technique testing. So ensure the technology meets the performance and safety standards and protocols. When you consider, is it meeting the standards and the protocols or not, you need to validate. Okay. When you see recently Boeing, no, so there is an aircraft crash happened. So Boeing aircraft undergo rigorous wind tunnel and flight testing to meet the regularity requirements. Why? They will try to see a rigorous way how it is when the flight testing, no? So it will undergo through with very rigorous testing, wind tunnel and flight testing, so that during difficult situation, how it will act. So they will do reverse testing, they will do validation. Not only they will do regular testing, they will do like very typical way. You see, you might have electrical people are there impulsive testing. what they will do? Not at standard temperature condition. People will do at very high amount of huge value. People will do the testing. Okay. Even when you have a Boeing aircraft is there, it is not under normal condition. Under worst conditions, is it the regulatory requirements it is meeting or not, also they will check. So not only normal way, they will do the reverse way. In typical situation, how my system will work. So like that, your validation should be. Normal ways through same procedure, it is working fine. Suddenly one element is damaged. Suddenly something is happened. Is your system is performing or not? Then all the testing conditions should be validated. Now, when I want to go for mass production, scale up and manufacturing, so transition from prototype to mass production. Okay. Now, rapidly, what happened? You know, no, recently COVID situation, there is a Moderna rapidly scaled up RNA vaccine production during COVID-19 pandemic. Why? There is a need. Mass production is required to the people. So there is market survey. There is a need. When you design any of the concept, what is the need? In what way I can give the solution? If you understand that, then the scale up and manufacturing will be easy. The market launch and commercialization also, the strategic plan, it has to go. Okay. Now previously, if you know, we used to have DVDs and rental things. Now Netflix, Amazon, so many, okay, online platforms, OTT shifted from rental to global. So you should know what should be launched, what should be commercialized, when, where, with which market, with which partnership. So these are the things. Now, let me take you to TRL levels. Whatever we discussed, so we are having first idea generation should be there, concept development and feasibility should be there. First, I need to generate the idea, select the idea, check the proof of concept. While checking the proof of concept, see the methodology, see the simulations, check the feasibility, then compare your simulation with the prototype, laboratory level, then after that, real world. You do the validation and do the testing during regular condition, during worst conditions. Once it is passed, scale up. Before scale up, you should take the certification from the respective people. Then after that, you have to go for manufacturing. Once you get the succeed, market launch and commercialization, we will go. Okay. Now, let me go to TRL levels. These are all we discussed. Now, when I want to go for TRL, that is technology readiness level. Okay. So to evaluate what maturity of technology from research to commercial product is going, like idea to commercialization, deployment, your particular basic research to commercialization. Okay. We are having mainly 9 steps are there, or 9 levels are there. Basic research, development, deployment. If you see, you have a basic research, development will be there, deployment. Under basic research, initially, I told you already previously, first one is basic principles will be observed. What does it mean? Idea generation. In this idea generation and discovery, selection of the concept we need to do. Initially, basic idea will be considered. Basic principles are observed. What does it mean? Ideas are generated. Ideas are selected through the brainstorming sessions. Through the scamper method, ideas are considered and you are checking properly. Then after that, what you will do in the first step, generation and selection of the idea. This is basic research. How we will do? Through the market review process, through review papers. You will select the concept. Then whatever you have selected, second one is what? Technology concept formulated. Now, one concept you have taken, for that one, you are downloading research papers. If you download a n number of research papers, in this concept, which algorithm to be considered, which methodology to be taken, which controllers to be taken, what parameters to be analyzed, under which conditions it has to be analyzed. This is technology concept formulation. Clear? Try to understand. The difference, try to understand. Easy way I will tell you. When you consider the first basic principles, in a research oriented, if you consider a review survey you are taking, you are understanding which concept you want to go. First one is selection of idea you are doing. After selecting that idea, second one is research level 2, TRL level 2 is you are formulating the concept. How you formulate the concept? Now it is not the review paper. You will download hundreds of research papers you will download. Then what you will do? First you have downloaded recent review paper. Now you are downloading research papers in such a way that what research is going on, which controller people are using for the same concept, which control strategy they have considered, which algorithm they considered, what parameters they analyze. So, and under which conditions this concept can be used. That is TRL2. TRL2 is formulating the objectives. First one is selection of the concept. Second TRL level 2 is the concept formulated, objectives created, and what parameter to be analyzed, on which method to be analyzed, what controller to be considered. This is the you have designed. Now, what is TRL3? TRL3 is experimental proof of concept. Now, you have designed the system. Okay. Now, you have selected these many controllers, these many strategies. Now, what you are doing? You need to do the design. Now, third TRL level in 3 in the sense you have designed the concept, you have done mathematical modeling. If you do the simulations, that is TRL3. Basic understanding, selection of the concept. After selecting the concept, formulating the concept, creating objectives. Not only creating objectives, you define the methodologies here. TRL2 is defining the methodologies, what to do, how to do, what test conditions will be there. Okay, defining all the methodologies, like these many controllers, these many experiments are required, or these many equipments are required, these concepts are required. So second one is technology concept formulation, including components, methodology, modeling, all mathematical related need to be designed in the second. Third one is whatever you have designed theoretically TRL level 2, experimental proof of concept. What does it mean? You are doing the simulation and you are going to do the prototype. So now what we are doing in the basic research, experimental proof of research in the sense, the proof of concept means you are doing whatever the mathematical modeling you have done, you are checking the feasibility of the mathematical modeling with simulation or through programming. Is it clear? Basic idea selection. After selecting the idea through the review paper, through the research paper, and you are confirming what methods, what methodologies, what equipments, what testing, under which conditions. That is second one, formulation. Third one is to meet that. Third one is doing the simulation. Which simulation I have to do? Okay, all the simulations has to be conferred. So in the TRL level 3, in the sense you are completing the simulation. Now, this is the basic research, TRL 1 to TRL 3. When it comes to the development, once you understood your theory, whatever you have taken, fundamental concept, theoretically correct. Mathematically, if you prove your algorithm is good. If you do simulation wise, yes, your concept is correct. Proof of concept is perfect. Then you are going to further step. What is that? Your technology validated in the laboratory. What does it mean? You will buy different components. You will design the circuit. You will perform in your laboratory if you have an equipment. You are doing the testing on laboratory level equipment testing you are doing. Now, Here you are doing the validation of your simulation. In tier level 3, you are validating your simulation with the theoretical concepts, mathematical designs. And tier level 4, you are validating your hardware results with simulation results. Now, if you know that under different conditions, if you validate the technology, if you prove that under laboratory you are getting good results, then what it is? TRL 4 you reached. Now, the people are asking TRL 5. Now, laboratory level, you are having certain limitations. You are having scale down values are there. Now, this laboratory level, I am taking to real world, relevant environment I am taking. Now, during that environment conditions, during scale up time, is the technology is working properly or not? I should understand. So now from laboratory scale down value to a relevant environment, we are going and we are testing under different conditions. TRL 5 is technology will be validated in the real relevant environment. If relevant environment, if you're able to validate that, the technology will be demonstrated in relevant environment. What is it, the difference? Now you have set up everything. Now during that environment, during all the seasons, during all the conditions, is your system working or not? One time if it works, it is validation is done, but technology should be demonstrated during all the testing conditions, during all the worst scenarios, during all the seasons. Then if it is working properly in the relevant environment, if you're able to demonstrate properly, then next you will go for what? System prototype demonstration in operational environments. Then you will go for deployment. That means here what we are doing is selection of idea, then confirming the idea, then doing simulation, doing hardware in the laboratory, then doing or designing the prototype, or your new concept will be validated in the relevant environment. After relevant environment, here you are approaching the testing external agency. You will work with the external agency. You will get the certification from the external agency. Then they will give you certification. Yes, whatever you have done in the relevant environment, yes, it is valid. That means you are demonstrated your relevant, your technology, you are demonstrating in the relevant environment. In the sense, government has different agencies. From them, you have to get the certification. If you get the certification, validating your in the relevant is okay. After validating, it is meeting the standard or not, it is meeting the protocol or not, it is good to take or not. If you're able to get the certification from them, then you are going for demonstration in operational environment. Now once your equipment is there, then it will be taken and it integrated with the system. Once if completes and qualified, then you will go for commercialization. So these many are there. Basic research to development, from development to deployment and commercialization. Okay, so these are the steps. So as I told you already, just repetition, basic research and development, what we are doing, as I told you, fundamental principles observed and documented. This basic research you will do from review papers. Now when you do the technology formulation, second TRL2 is what? Under basic research only. Technology 2 is, TRL level 2 is technology formulation. The concept, proof of concept, feasibility we will check. Mathematical modelings we will do. TRL 3 is validation. The proof of concept will be validated using your simulation studies. Now, prototype development and refinement. Now, TRL 4 is small scale. I told you, no, small scale prototype will be developed in the relevant environment. TRL 5 will be large scale prototype will be demonstrated in the relevant environment. Then the technology will be ready for the system integration. Then we will go for demonstrate the system successfully in the relevant operating condition. Here what we have done, in that environment we have designed, environment we have demonstrated, we have taken the certification from the person. But now you take this prototype, suppose you design one EV charging infrastructure. Now this has to be integrated with the grid, isn't it? Whatever the design you have considered, that prototype has to be integrated with a particular concept. That means I have designed a PV integrated EV charging station. The PV integrated EV charging station has to be integrated with the grid. Now, what I will do, TRL 7 is you are deploying or demonstrating the system in the relevant operating condition. Now, then if you are qualified, then you will go for commercialization and you will take the approval for full commercialization. These are the levels. So basic research and development, prototype development and refinement, then deployment and refinement. These many are there. So when you see properly, basic principles we are observing. First, disruptive research it is called. Disruptive research is what? Understanding the principles, technology concept formulation. One is disruptive, applied research, demonstration, manufacturing. Now, disruptive research, TRL level 1 and 2 will come. Just selection, formulation. If you do, after the technology, your applied research in the sense, TRL 3, 4. What you are doing? You are applying some concepts. You are applying controllers on the particular system. You are applying control strategies on the particular system. You are adding some optimization methods in the particular system. Then you are checking the proof of concept. You are checking it in the laboratory. After that, once it is tested, your idea you checked, then prototype, then first test product, then commercialization. Now what after that, what you are doing? Then relevant world, certification, system prototype, after demonstration, modeling. So these are the things. Now, when you are doing this, who are involved? When you are going from TR level 1 to 9, who is involved? How it is? So when you go ahead with TRL 1 to 7, yeah, you can understand 1 to 3 basic research only, 4 to 6 development, 6 to 9 deployment. When you do 1 to 3, academia mainly involved. TRL 1 to 3, you will involve with fellow beings. You will involve with your research, basic research technology. You will involve with your own R&D. Okay, you will involve with only your fellow beings in the other departments. You will involve with other groups. So basic knowledge deployment TRL 1 to 3 is to do selection till simulation and basic prototype. No, you are depending on the academic groups. Okay, suppose I want to go validate in the lab and real world. I want to go ahead with then particular not only knowledge development, technology development. I want validation of the research, then in the relevant field, and demonstration if I want to go. For technology transfer, your just academia is not sufficient. You need to do the collaboration with whom? Industry. Industry, and you need to do technology development. Suppose in the similar manner, if I want to go ahead with a market launch, commercialization, you can't do the commercialization if until unless if you have own startup, until unless if you have own incubation centers, until unless if you have the facilities at your organization or maybe industry. So what we need to do, you have to collaborate with any of the industry for commercialization. So the initial basic research will start from academia, combining with your own people, combining with other department people, combining with other parts of India academia people. So TRL 1 to 3 I reached. That means understanding the concept, selecting the concept, applying the concept, then selecting the designs, doing the simulations, validating the laboratory. Till then, academia okay. But when you go for prototype development, it is mandatory. You're doing some technology development, not simulation now. You should have industry. Why? You're doing the innovation. When you do innovation, new components required, new equipment required. You're not doing delta X. Suppose now silicon converters based converters are there. Now you are going with silicon carbide, SiC based, gallium nitride, GaN based converters you are going. So which is maybe not that much vast available. So you will discuss with the industry what is your need. So you will modify the circuit. You will substitute the circuit. Okay. You will redesign the circuit. For redesigning the circuit, suppose if you use whatever in the market is available, how you will go with the commercialization? If you want to go ahead with the commercialization, you should have a new technology or new components. So you will tie up with the industry and you will design the new components. You will design new equipment or new prototype by networking with industry people. After that, with a mutual understanding with the testing, and only industry not sufficient, then at TRL level, you need to demonstrate to the third party who gives certification. Then only I can go with business development. I hope you understand. So when you consider this level of understanding, first government is involved research and development, then field validation, scale up and commercialization, develop deployment, market transformation. Here who involves TRL levels? There is MRL also. TRL is technology readiness level. MRL is market readiness level. Okay. TRL is academia is required, basic concept laboratory testing. Okay. But when you're designing the concept, you have a depth knowledge is there. Technological value of depth is very deep, low. You have a good technical skills, but not product skills. Now, after that, what you have done? TRL 1 to 4, then you have tie up with industry. If you tie up with industry technology transfer, now again, you went with product prototype. When you went product prototype field type, if you are done, then commercialization depth is there. For the commercialization depth, again, industry you have targeted. So here industry will place a more role, government will place a low role. So when industry comes, commercialization will increase. After that, investors will start. After that, banks, then market readiness will go. Okay. So this is what we are having TRL 1 to 9. If you go basic research, feasibility, technology development in the laboratory, in the environment, then technology demonstration, then system, subsystem development in the main systems, then after that commercialization. These are the steps which are involved for design. Okay. Now, can you tell me? Sorry, he said like 5 minutes is there. Okay. So now it is open for the queries. Just 2 minutes. Let me cover you. So what we have taken is we have considered ideation in the sense 3 steps. Generation of the idea. Okay. Let me cover. We are having generation, selection, implementation. Okay. So generation is happen with 2 things. You are generating from internal sources, external sources, and while generating the internal sources, external sources, you are doing with internal sources, either own R&D, other department employees, with the customers and competitors. You are doing internal and external. Now, after that, what you are doing? Selecting the idea. To select the idea, we followed 7 steps. Brainstorming in the sense, group of people, ideas are taken. After taking the idea, you are grouping that. After grouping, mind mapping you are doing. After doing the mind mapping, then you are doing the scamper. First, initially you are taking so many things. You are doing the focusing groups. You are doing the mappings of mind mappings, how the equal groups are there. Then you are doing substituting your idea. You are combining the ideas. You are adapting it. You are modifying the system. You are putting all the ideas together. You are eliminating the things. You are reverse. You are doing. That means, so in this idea, Initially, you will do the brainstorming. After that, groups you are creating, your mind mapping, in the sense fixing the relevant people, and then you will do what area to be substituted, what component to be substituted, what ideas together can be combined, which need to be adapted, which is sustainable, which need to be modified, what to be put together, which need to eliminate. Then you will go ahead with, after deciding this step, then you go ahead with design finalization. Then you will do reverse thinking and sketching. These ways you are selecting particular idea. Now, once you select this idea, what you are doing, then implementation. When you are implementing, you are defining proper objective. Customer centric, you are going all times. You are involving the right people, defining the borders as per the objective. You challenge all existing things successfully you are executing. This is implementation. Then when you do that, once implementation is happening, for that one, there is TRL levels are there. So first selection of the concept, then proof of concept you are checking, simulation, theoretical design things, prototype, validation, testing under different condition. Then if it is validated in the laboratory, taking it to environment, real environment. Then if it is validated there, then it is demonstrated with the people, right people, taking certification, scaling up, manufacturing of things, market launch, commercialization. These are all the things comes under TRL level 1 to 9. Basic research involved, developing prototype is involved, in the laboratory, in the real world environment, taking certification, then deployment is commercialization. Now it is open for the queries, please. I hope a little bit I reached. Can you tell me any queries you have? Sorry, I took more time. Is it okay? Do you understand?
Yes, sir. Yes.
Yeah. Is there any queries, or at least tell me? So we have started from idea generation to
Yes, sir.
till
Now we open.
TRL.
Yes, sir. Thank you so much, sir, for your insightful presentation. Now we open the floor for question and answer session. Participants may kindly put their queries in the chat box, or they can simply raise their hands.
Yes, Supriya.
Yes,
Yes. Yes, continue, ma'am.
yes, Supriya Chaugule, ma'am. You may proceed with your question.
Ma'am, please proceed. What happened? You can ask.
Supriya, ma'am, are you there?
No.
Yes,
Do you have
ma'am.
any query?
Yes, ma'am.
Please, ma'am, tell me.
Any other participant? If you want to ask any question.
At least do you understand how to from generation to till TRL we went? At least do you understand? My motto is Delta X. You should learn from the first session. That is my intention.
Yes. Yes, sir. Yes. Yes, ma'am. Rajni, ma'am.
Yes, ma'am.
Okay. Ma'am.
I think there are no any questions, so you can conclude the session.
Okay, sir. Okay. Thank you, sir. Thank you, Dr. Mikili, sir, for a deeply insightful and richly reference session. We truly appreciate your time and guidance, sir. The way you explain complex industry 4.0 concepts in such a simple and structured manner was truly commendable, sir. Thank you so much.
Thank you, sir. Thank you very much.
Thank you, ma'am. Thank you, sir.
Yes.
Thank you all. I made you like, okay, I hope, right? I clear. Okay. Thank you. All the best for next sessions.
Yes, sir.
Yes,
Yes.
sir.
Thank you.
Thank you. Thank you very much, sir. Nikili sir,
Thank you.
thank you very much.
Bye.
Thank you, sir.
Okay. And participant, we are providing here feedback. You can feel the feedback. Okay, for the first session. Thank you. Ma'am,
Yes, I request all the participants to kindly fill the feedback. The link is provided. Yes. With that energizing start to our technical journey, we now move forward to the second session of the evening. Our next distinguished speaker is Mr. Arjit Chatterjee, Chief Business Officer at Czentrix, with nearly 3 decades of experience across software, research and development, product development, sales, and marketing. He has served in senior roles at Infosys and also founded an edtech startup, an alumnus of BIT Sindhi Electrical Engineering and ISB Hyderabad as an executive MBA. He drives global marketing, business development, and product innovation in customer experience technologies. He's passionate about AI and ML and their transformative applications in marketing customer service. He frequently delivers workshops and training for academia and industry. We are honored to have you with us, sir. Now, we are eager to listen to you, and I request you to start the session.
Thank you, madam, and good afternoon, good evening to all of you.
Good
I
evening,
know
sir.
it's a late evening now, so
Good evening, sir.
good evening.
this session I will try to make it a little interesting with some industrial experiences. Okay,
Yes, sir.
and I would suggest because there is easy to unmute the mic and ask questions, so you do not have to wait till the end of the session. If anybody has any question or suggestion, see, what I will now tell you is not typically from an academic perspective, but from my experience in industry perspective. So we will see certain things which you do not see, or you may be seeing certain things which we don't see. So feel free to comment or put your queries, okay, and we will see how much we can cover in this session. Okay. So with that, I will start sharing my screen as well. So let me just pull up the presentation. Okay. So the discussion we were supposed to do was more on design thinking, but I brought up the product differentiation because why is the question, why design thinking? Okay. Or what is the need of design thinking? So as Professor just introduced before my session, about the innovation, the approach towards innovation, uh, which is definitely the most important part of how you start building a product. Tomorrow also I will conduct another session on new product development. Okay, and but today we will discuss on design thinking, the philosophy behind design thinking, and I will try to give more industrial examples. So this slides that I will be covering is more looking at pumps and valves. I understand most of you are from the manufacturing or the industrial departments. So I will try to cover examples which will suit from your perspective. Okay. Uh, Is it okay if I continue in English or shall I switch in Hindi? No, just to ensure that everybody understands what I'm saying. Sorry? Echo, right? Okay. So let me bring up the course objectives, okay? So what we will try to understand today is about product differentiation in manufacturing sector, okay? Then we'll get into the principles of design thinking and how design thinking can help industry to create or innovate the existing product. Okay. So, and so it is not limited to product. It can be also related to processes also. So it can be product slash process. Okay. And then explore the practical frameworks to enhance product features for improved business outcomes. So what is the framework? We will talk about design thinking, but how do you apply that framework? Okay. these methodologies, and how you or as a cohort can apply these things depending upon the market demands. Okay, so this is broadly what we will try to cover, and this is typically a journey where you are trying to enhance your existing product offering, enhance your processes. Okay, so before that, design thinking, I thought of bringing this point is what is the need for product differentiation. So why it itself required to bring design thinking, because there is a overarching need for product differentiation. Okay, so let's look at the manufacturing industry. What is the challenges? Okay, so as you know that more and more saturation is happening in the market. Okay, so today if you see in any it is not only in industry of manufacturing, every walk of life, given say in the space of say software. Okay, similar softwares are available, so many different type of companies are offering, but it is happening is that with more supply, okay, the market is going to saturate, or it is saturating actually. Okay, and with the advent of AI, okay, now it is far more easier to build things than it was earlier. Okay, so just by writing certain prompts, you can now build a software. Okay, so that means more people can do, which means more saturation is going to happen, and that is one of the challenge which will not only limit to manufacturing but all parts of industry that we will see. Okay, so what happens when there is a saturation? There's a price war. Okay, that means more people are trying to compete. Okay, and there's a price war and there's a commoditization. That means everything looks like a commodity. Okay, and when it looks like commodity, then the price, the only thing way the price goes is downwards. Okay, so third thing is the another dimension which is evolving is that customers are expecting new things. Okay, there's an expectation from the customer perspective. Okay, so which again puts more pressure in, from a manufacturing standpoint, what is the new thing that the organization has to offer, deliver, right? And these are, I would say, the top three items when we look at what is the need of this differentiation. Why should company A, which manufactures almost same thing like company B, would like to differentiate? Okay, so when the market is saturating, okay, any player would like to stand out in this competitive market. Okay, so if you see the automotive world, okay, so today there are so many players. Okay, there are not only Indian players, there are Chinese companies that are coming, European companies are there, right? So any manufacturer, okay, will try to stand out. Okay, so in this competitive market, and what you see that sometime back, in the cars, okay, that you and I use, we're not having a sunroof or moonroof. Okay, which was not necessary. Today also it is not necessary. But the sooner one company introduced it, okay, so they made a product differentiation by saying that no, they have a sunroof, okay, or moonroof. Okay, then immediately if you see in next 1 to 2 years, almost all vehicles in that product range, okay, for that customer segment, okay, everybody did the same thing. So what remained as a product differentiation for one player very soon was covered by other players. Okay, so that means you have to continuously differentiate to be ahead. And second thing is, when there's a price war, okay, given all the factors, right, finally what customer hooks to is if everything is very similar. Okay, so today, for example, there are platforms like Swiggy, Zomato, Zepto, Blinkit, you name what, this Big Basket, Amazon now, right, Flipkart. So there are so many platforms from which you can order the same food. Okay, and there's a huge price war if you see for 1 rupee, 2 rupees difference you will see between the platforms. But what is sticking with is the customer loyalty, okay? That if you are using say a Zomato or say a Big Basket, okay, for a long time, you are more likely to stay, okay? And brands are trying to ensure that the customer loyalty remains so that they do not have to really get into the price war. Okay? The third is that perceived value, okay? So when you, so this is another very important thing for a manufacturing point of view or for any kind of industry perspective, is that how do I enhance that perceived value? It is not necessary that it has to be a real value, okay? Sometimes the value is also perceived by the customer, okay? For example, this has been very well done by luxury brands, okay? So if you see the most of the luxury goods, okay, they are really high quality, okay? No doubt about it. But average product and their product has quality difference for sure. But their customers who are going to buy those luxury products, okay, they they see more from the perceived value of the brand rather than the actual value that they are deriving. For example, if you buy a designer bag, okay, versus a normal bag, okay, the value that you are deriving from a designer bag is nothing more than a regular bag, okay? But there's a perceived value, okay? And that's the story behind the experience or customer expectation. And brands have to try to ensure or create a differentiation by enhancing this perceived value, okay? And once you are able to enhance this perceived value, as a brand, you can do the premium pricing, okay? So remember, my session will be both from a business as well as from a technical perspective. So I will give you a flavor of both. And this, I think, is more required because that's how what the industry is all looking for. That faculties have very good understanding, not only from the product technology, or I would say process perspective, but they also understand from a business perspective. So you will excuse me if you hear this kind of words like premium pricing, customer loyalty, and other stuff, but these are very important for from a consolidated view of what the industry is looking for. Okay. So this slide, what I am trying to re-emphasize is that there's a need for product differentiation, and the need is because of the challenges that are in front of manufacturing. And these challenges can only be differentiated by creating that product differentiation, right? Okay. Let's say some examples. So customizable features in industrial pumps to cater to specific industries, okay? So this is, again, remember I said that we'll talk about pumps and valves to relate it more from a manufacturing and industrial point of view, okay? Similarly, adding some smart capabilities, IoT enabled, okay? Not that everybody is doing, okay? But there are companies who are doing it and they are able to create that much needed product differentiation, okay? Now, I know that this is what the reason for product differentiation we stated right now. Just to re-emphasize it, to understanding the product differentiation is creating unique features, qualities, or benefits in a product that set it apart from competitors. Okay, this is exactly what we were covering in the previous slide, but it is just like a sentence or definition. Okay, in the manufacturing sector, this could mean enhancing energy efficiency, durability, or connectivity. Okay, so it's not limited to that, but just to highlight, because this will always come in our mind that, okay, in a valve, okay, or in a pump, okay, what is the product differentiation? Okay, so few things that can pop up. Okay, can it be more energy efficient? Okay, can it be far more durable? No, able to know face the different no I would say a high temperature or low temperature, extreme weather conditions, durability perspective, and also connectivity, because today with this IoT and industry 4.0, this is very normal to expect that it should be, all the equipment should be connected. So let's look at the various types of differentiation. Okay. So first, I will cover one by one the functional differentiation, performance-based differentiation, customer service or value-add differentiation, and aesthetic or design differentiation. Okay. So let's look at functional, which is very simple to understand, is advanced technology. Okay, functional, so advanced technology empowers the functional differentiation faster. Okay, such as IoT capabilities to pumps to improve monitoring and control. Okay, so one example like a pump with a self-diagnostic features. Okay, so it is obviously a functional differentiation. Okay, second is the performance-based differentiation. So we said about the durability part of it, right? Or efficiency, noise reduction, okay? So this kind of things which are not functional, okay? But they lead to a performance improvement. And that is how that product can differentiate itself from a performance standpoint. Okay. So valves that perform reliably in extreme conditions. Okay. So that's a functional performance based. Third one is the aesthetic design. Okay. So innovative design for easier installation or better ergonomics. Okay. Again, the discussion is from this manufacturing world. Okay. It's not from software where aesthetic and design or something things become more from a UI UX perspective. But this is more about the how easy it is to install. Okay. Or better ergonomics so that it can be handled properly, right? And last, the value add features or customer service differentiation is offering maintenance, tracking system, extended warranties. So these are not necessarily in either of these blocks like functional or performance or aesthetic, but it also adds to a huge amount of product differentiation if the product or the adds these kind of values, okay, like remote monitoring maintenance, predictive maintenance of the product before the product um, uh, requires a maintenance. Can I detect it, right? So I can save downtime, okay, or extended warranties so that the product running opex does not go up through the budget, right? So a valve manufacturer providing predictive maintenance software, okay, is a good example to create a product differentiation. Okay. Any question anyone has on the product differentiation? Because this is going to segue into the next discussion about design thinking. Okay. So I hope you guys have understood the product differentiation and the need for product differentiation from a business standpoint. Okay. Let's see some case studies to ensure that whatever we have been now discussing so far is actually applied in the industry. Okay. So let's see this smart valve by Emerson. Okay. So it has the predictive maintenance and downtime. It is now having these capabilities in terms of differentiation. Okay. So downtime they have reduced by able to do the predictive maintenance, enhance safety and reliability. Okay. Energy efficiency and cost savings. So remember the performance based differentiation we were talking about, remote monitoring and operational flexibility. Okay. And improve customer value prop. Okay. So most of the types of differentiation that we discuss are actually covered by Emerson in this smart valve. Okay. Similarly, if we look at this Grundfos, okay, their energy efficient pump, okay, how it differentiates with their competition, okay. So energy efficiency and cost savings, okay, in their design itself, okay. So again, another part is the carbon footprint reduction. So about the ESG and all the environment policies that are coming in the industry. circular economy initiative so that it can be reused, components, the material can be reused. Advanced energy optimization services built into the ground, this energy efficient pumps. And then they have done, interestingly, is a sustainability partnership. Okay. So that means it is not only energy efficient, the sustainability parameters are taken into account, and they are partnering with no other providers so that the sustainability ecosystem can be enriched. So now, usually I ask, because I try to let people or participants think about. Okay, so usually, like, can we identify any existing differentiator or potential of area of improvement in your current products? Okay, so this, because this session is also done with people who are into manufacturing, so it is like a 1 minute of thought going in, and participants can tell, yes, I have seen, or there is some area of improvement that we can see in our product line to improve to create the product, the differentiation. So does anybody want to volunteer and say about any differentiation or some area of improvement that they see in your experience? Okay, I can understand. It's quite late in the evening, so people will be waiting for this session to get over. Okay, let me move into the design thinking area. So now, so far, what I have covered in last 30 minutes is what is the need of, we started with design thinking. So why design thinking? So I said we need to create the product differentiation. Then we said why product differentiation? Okay. Then we talked about the situation in the market, why companies have to have no other option but to create product differentiation, the various types of product differentiation, and with couple of examples how these companies have been creating product differentiation in their offering. Okay. Going forward, let's get into design thinking. Okay. So design thinking is a methodical approach. Okay, it is proven, and design thinking, actually encompasses all kind of areas. Manufacturing can be one. Okay, it could be any process point of view. It could be, for example, nothing to do with manufacturing. It's a healthcare. Okay, a hospital system. Okay, or any kind of service oriented. Okay, business, or say a retail chain. Okay, or supply chain. Okay, so anywhere. No, it is not limited that today we are orienting this discussion from a manufacturing standpoint, but design thinking principle is quite wide. Okay, and it can be applied in any walk of life. Okay, it could be applied to any of your departments and not limited to manufacturing. Okay, so what is design thinking? Okay, so we will try to give some definition also, so that we suddenly somebody asks what is design thinking, so we cannot say in such a lengthy fashion. So we will say that is a customer-centric approach that fosters innovation. So remember, we started with that we need a product differentiation, right? Product differentiation means innovation. Okay, some improvement has to be done. Okay, and it is not incremental improvement. That means that, okay, now the bearing is able to take X amount of load. If we increase able to take X plus delta X, okay, it is an incremental improvement, but that will not necessarily require a design thinking. Okay, but if you say that no, the valve that I am manufacturing, okay, can I reduce the cost of manufacturing by significant percentage, maybe 10-15%, right? Or can it be used in multiple different applications, right? So then you say that it is not an incremental, because if I apply, make it so generic, okay, so that it can be used across different applications. So you know the cost, the scale of economy of scale, I can benefit, and I can make a lot of this valves for different applications, right? Instead of application specific valves. Okay, so I'm just saying that remember it in mind that unlike there are other processes in industry that you are already aware, like Lean or Six Sigma and others, okay, which are focused towards making this incremental improvement. Okay, so but here in design thinking, the objective is to make it's a non-linear approach and go beyond this incremental improvement. Okay, reimagine products entirely addressing unmet customer needs effectively. Okay, so this is very powerful sentence. Okay, so how many times we reimagine the product or services that we are offering? Okay, so basically it is not advised. Okay, so if you say go to a manufacturing plant and say, hey, uh, why don't we reimagine and lay out the entire thing differently, right? So you will not be most welcome in that plant. Okay, because they work on something that has been tried and tested for a long time. Okay, and reimagining all these things is very expensive. So most of the conventional organization would not do it. Okay, and also not doing it also limits their ability to innovate as well. Okay, or how many times we ask this question whether there is an unmet customer need. Okay, that means we are providing this service or this product. Okay, it may be meeting certain customers requirement. Okay, but is there a segment which is not met? Their customer needs are not getting met. Okay, and how can I meet them effectively? Okay, so this is all about thinking, and we will call why it is called design thinking. Okay, so it is first this very thought that can we make this kind of a change? Okay, can we create certain kind of a disruption? Okay, and then how can we do this disruption? Okay, because it is not one scientist who is sitting and thinking. Okay, it is an organization or team. Okay, and there are various stakeholders. So then you need to apply a more guided process. Okay, which ensures that these things are done in a more, I would say, structured way, or a way so that everybody is involved. Okay, it is not one guy thinks that we will have to change this and he starts doing the change, right? It has to be done with consent of all the stakeholders, and that is why a process has been evolved, which is this design thinking. Okay, and we talked about the differentiation of GE and Grundfos. Okay, and they have been able to bring this differentiation, product differentiation, by applying this design thinking in their product development, in their process development, in their service segment, or even in the customer experience point of view. Okay, so and it is like a thing that you continuously do. Okay, it is not like we did a design thinking workshop, we thought this has to be changed, we did it, and then that's it. Okay, so it is something that you have to continuously do it, improve it, and further improve it. And that is like market is also demanding, as we said in that slide, that customer expectation is ever growing. Okay, first there was no electric car, and then came electric car, and then people said that okay, 300 kilometers in single charge is great. Okay, we'll be happy. Now people are saying, oh, 300 is not much. Okay, we want 600. So this kind of expectations are going to happen, and that's how life is. Okay, and that is why innovation, is needed by organizations. And one way, there are various other innovation techniques. Okay, one proven way is to apply the design thinking. Okay, let's work on the stages of design thinking. Okay, so with this, we have understood what is design thinking. Okay, or problem is the need of design thinking. Okay. So basically, if you see, there are five main five things. Okay, and these overlaps each other. Okay. Design thinking, the first one is empathize. Okay. So empathize means feel. Okay. Because see, you may be manufacturing a valve, but are you a user of valve? Okay. No, not necessarily. Right? So most of the companies who are making it may or may not be, no, experiencing it. Okay. The utility of it. Okay. So that means we who are involved into the manufacturing of it, okay, should understand the needs and challenges of the user, okay. And to me, it is not that what what is visible to your eyes, okay. It is also to empathize and feel like how a customer would experience this product or experience these services, okay. There was an interesting example where if you see a simple thing like a trolley that we use in a supermarket, right? Now there's a company called IDEO in California, okay, who was given this task of can you innovate or can you make any difference to this trolley? And which is just very simple and no, nobody thinks of how why should I go and innovate a trolley? But just as a no, workshop they were doing, okay. So first thing that they did was this empathize, okay. So they said that let us all observe how customers are using trolley in the supermarket. Okay? How what is their usage, how they are using it. Some and then there are different kind of customers. Young customers are there, old senior citizens are there, right? So what is very important, and that's where the entire exercise shows that this was the most important part of their innovation part is that they invested a lot of time to understand the user's need and what kind of challenges they are facing. So when we do this design thinking workshop, we will definitely get involved into empathizing the customer or the stakeholders needs. Okay. Then there is a clear articulation to the problem. So as technical people, we all know that definition is very important. Otherwise, no project will get into completion because if it is abstract, if it is like a feel, but no, they are not very clearly stated. Okay. So whenever we are embarking on a design thinking workshop, we should be watchful about that. The team, after empathizing, after seeing what is the unmet need, how users are, what are their challenges, all these things, then come and clearly articulate the problem. Okay, what is the problem at hand that we are going to tackle now? Okay, so define it. Okay, third is where the light bulb moment happens. You ideate, put up certain ideas in some sticky notes, place it, discuss, debate. Okay, so this is where you generate creative ideas to solve the problem. So you have visualized it, or if you have not visualized, some team members has visualized it and narrated it to the team. We have now defined the problem, and then with experienced people around, generate creative ideas about it. And then next is the prototype. Okay, a scaled down version because manufacturing anything is super expensive, so we cannot get into the manufacturing. We all know that prototyping is essential. Okay, so create scaled down version and then test. Okay, like getting feedback, and this is where the refinement happens. And then continues this iteration. Now, this is very important, is that it need not move linearly every time. Okay, so for example, you figured out that while testing, okay, that means soliciting feedback, you came and figured out that certain things that was expressed by the customer or stakeholder is not there in the product, right? So you don't have to go again, empathize, define, ideate, prototype, again test, okay? So you can say from test, you can go back and you say, no, no, definition is correct. We don't have to go into that. Let's get into ideating and say that how do we take up this challenge? So it is not that I have to go through step 1 to 5 in a linear way. I can jump from one to another, or from test, you can go back to the prototype and say that no, we have to modify the prototypes. No, so what I'm saying is that it is not a very complex and very, I would say, academic process. Okay, if you, sit back and say, hey, this is something that it's very normal to do like this. Okay, so why not define a process? Okay. But you remember that in industry setup, okay, you are going to interact with a lot of different people, okay? And if you say, hey, let's ideate, they do not understand what is this part, okay? So that is why to have a process in place so that people, the team who are going to apply design thinking knows, okay, why we are currently, getting into the problem definition stage, okay? Or we are getting into the prototype stage, okay? So understanding is very important. And by design thinking, what we want to achieve is create that product differentiation, what we wanted to start with, okay? And these are the various stages which will lead us to create that the product differentiation, okay? Through this journey or the stages that we will go through of design thinking are as follows. So empathize, define, ideate, prototype, and test. Okay. Let's go with some examples to strengthen this. Okay. Any questions on this? Any suggestion or anything that I may have missed out?
I request if there are any questions or suggestions, please feel to
Yeah.
ask.
Yeah, you guys can unmute your mic. Okay. You can ask in Hindi, English, anyway. I can, speak both of the languages. Hmm. Okay. Let's look at a practical scenario. Okay. So remember, as I said, that it is non-linear. So you can see those arrows. So they are moving back and forth. So the first one is going very linear, one after another. But this is the very first time. It's not that you empathize, define, again, go back to empathize. So first time you go through this path, okay? Then you can go in any direction depending upon which stage you are, okay? So that shows us that it is non-linear, okay? Now let's look at the framework and apply it practically in a industrial standpoint. Okay. So for example, first is that we conduct interviews, surveys, or site visits. Okay. So we want to look at a new valve design. Okay. And this is because we wanted to create a product differentiation. So if we want to do it, what do we do? Okay. So as you know that the guys who will be doing this design thinking are not typically going to be using or the users of this valve. Okay. So you need to go and interview people or survey people, okay, who are using the valve, or go to the site where these valves are installed. Okay. So this is very important, as I said, that this is where the majority of the time should be invested. I told about the IDO workshop. Okay. If you skip this process, or you just say, okay, I've done 2, 3 surveys, I can understand. Okay, let's get into the define stage now. So this is where people usually do this mistake, is they want to speed up the things and just rush towards the prototype stage. Okay, because as engineers, we are always wired to first create something. Okay, let's make something work. Okay, but first, because in the first interview, if you do not capture more of these things, next time you go to the same person, he will not be open enough to share all these things, right? So you go to a field technician and figure out what is the difficulty in installation of these valves. Okay, but you just ask 2, 3 questions, and then you just say, okay, I got the problem. And you do not ask other technicians and other things, so you will not be able to gather that kind of insight. Okay, which will lead you to the define stage. Okay. So like here I am giving you some example. So here in the define stage, after interview and all these things, the team feels that this is very important, how to create a pump that reduces energy consumption by 20%. Okay. So this is kind of, talking to the stakeholders and all this. Finally, you come to with one defined statement. Okay. Should there be one? Should there be multiple? Yeah, there can be multiple defined stage definition of the, but you are tackling one problem at a time. Okay. Maybe it is the team's discretion. It is not a doctor's prescription that you have to do like this only. So if your team finds that there are multiple problems that needs to be addressed by applying the design thinking in this iteration, they can come up with, but it is more efficient that you take one at a time. Okay. So now when the team has this problem statement, how to create a pump that reduces energy consumption by 20%, right? Then comes the ideate phase. Okay. This is the most exciting part, because this is where you bump across with a lot of creativity, lot of argument, lot of refusal, lot of things happens at this stage. Okay, if you start doing uh, the the design thinking workshop, you will see that this is the most noisy session. Okay, where people are jumping around and say, hey, you do not know, I am in this area for a long time, this is how it works and all these things. So there will be very interesting things. Okay, but most important thing is that during the ideate phase, okay, avoid killing the suggestion. Okay, because many times people overrule by saying that a younger team member, okay, who has less experience, okay, comes up with some crazy idea. Okay, and the senior member can try to kill that. No, no, this is how it does not work. Okay, so that's where you kill the opportunity to create that iPhone. Okay, if you let the idea flourish at this point of time, you may create that aha moment out of this product, or this design thinking workshop. Okay, so here I'm giving, this is the example that the team comes with the adding variable speed drives to pumps. We talked about energy consumption. Okay, how do I reduce energy consumptions? Okay, so it's just a this may not be a very relevant idea to apply, but let's say this is the idea that the team has come up with. Okay, then the team has to work on a prototype. Okay, great, this is a good idea, let us see how we design this. Okay, so now prototyping has become, rapid prototyping has become very easy. Okay, and you have the 3D printed printers and other things, so you can now make it, not only visualize it, but to test it also. Okay, so the ergonomics feature, the how usable it is, right? And the next step is the test phase. Okay, where you can now do a field testing, a new valve, a high pressure industrial setting, how it is working, right? Now, at any point of time in this stage, okay, the team can say, okay, maybe we have not captured, when we tried testing it, we did not see that the right problem statement was defined. Okay. Is there anybody, any question? Okay. If there is no question, kindly mute the mic. Okay. Thank you. Okay. So what I was saying is that this example is just a guideline or a instruction to show that all the 5-stage process are so important to achieve the outcome from the design thinking. Okay. At the same time, it is very much non-linear. It does not have to move from one end to the another end. You can do crisscross, jump across. The objective is that the, the tested product that we are at the final is what was the input that we got during the empathize phase. Okay, through the customer interviews, surveys, and all these things, right? So that is when you test it, go back to those guys, who had given you the input, okay, that we are looking for a more of energy, efficient, or it should consume more less electricity. So how can I need a pump, which consumes less electricity, and without compromising on the performance, okay. So now you go back at this stage and show and see that no, this is working fine. The energy consumption has come down, but its performance is intact, right? So that is when you say that, okay, the design thinking workshop has resulted into the much needed improvement of product differentiation that I was looking for, okay, or the team was looking for. Okay. I'm not sure. Is it a 1 hour or 1.5 hour session? Okay, I'll continue. I think it was 1 hour. Anyway, there are a few more slides. Okay, then we can wrap up. Okay, so applying design thinking to manufacturing. Okay, so this we have partially covered. So we talked about interviewing customers, understand pain points in pump and valve usage. Okay, so we talked about the example where we talked about a energy efficient pump for cost saving. Okay, identify problems such as energy inefficiency or maintenance difficulty. Okay, so this is where the team writes down a definition. What is the problem I'm going to solve? It's like a mathematics. So you write a problem statement. This is the problem, right? So that's where the define comes. Okay. Ideation is where we talked about the brainstorming, like smart monitoring system or self-cleaning valve, or how do I uh, provide the variable speed drives in this pump. A prototype is where we are creating this mock-up prototypes, right, to see if it is adhering to what we define the problem statement to. And then is the deployment in pilot projects and feedback. It is written in a way so that I'm repeating the same thing couple of times just to ensure that if it is something new, multiple times, it is needed to be or mentioned so that we try to apply it in the same way. So empathize, define, ideate, prototype, and test. Okay? These are the basically the 5 stages that you will go through when you are applying the design thinking. Okay. Now going back, okay, remember that we started with the product differentiation, okay, and how design thinking fixes that problem of product differentiation. Okay. So now going back to the product differentiation framework. Okay? And remember when we were talking about product differentiation, we also said that product differentiations are of different types of differentiation that we can create. Okay. Now, this framework is important to understand that first identifying the market gap. So when we said that no, we have to create product differentiation. So what is the framework? How do I think as a team that what kind of product differentiation shall I create, right? So identifying the market gaps, that means I know that is not the this particular product is catering to a particular segment of market, right? But there's another segment that is the customer needs are not met. Okay. Should you meet it is another question, because there's always a no equation, because whether the customers are willing to pay that price, or for that price point you have to create a different Tata Nano kind of a product. No, all these things are important to evaluate. But first is that identifying the market gap, value proposition, as I said, there the benefit of this product offering. Okay, feature, which no feature should be there, and which has the highest impact on these features. And then is the go-to-market strategy, that what do I communicate? So I said, no, the perceived value. Okay. So what I communicate is what gets into the mind of the customer, right? So for example, silent pumps designed for noise sensitive environments like hospital. Okay. Now the word silent and hospital, okay, can you relate these things, right? And this is very important how you finally reach to the customer and make that product differentiation. Okay. So this is a case study. Let me see. Smart pump, high maintenance cost and downtime. Okay. So this is the problem. Okay. This is very small. No, it can be a lot bigger. No, what is maintenance cost? What is high? Okay. What is downtime? How much is the downtime? So I'm not getting into that. Okay. So, like for example, with the design thinking workshop, we can provide a solution like integrate IoT for predictive maintenance. Okay. And this is the outcome that we get, that you can reduce the downtime. We can increase the customer satisfaction because downtime going down is inversely proportional to the customer satisfaction going up. Okay. And then you have a before and after metrics comparison. Why I'm saying this is a case study. Essentially, this today what we are discussing is done through actually a workshop. Since this is a virtual session, we are not able to do a workshop. But typically, the case study is all about experiencing it. Okay, so doing a short workshop where we go through these phases and understand it. But since we are not having that, I would say, privilege to do that workshop, so we will know. I'm just explaining you through this case study. Okay, so basically, in this design a differentiated valve product. Okay, so you go and talk to customer or users of the product and understand, for example, corrosion in chemical industry is a pain point, okay, for the valves. Brainstorm some innovative solution, okay. So it's a just a pointer, okay. The people who do this kind of workshop, they come back and say that this is kind of solution that they have brainstormed, okay. And then creating a prototype, testing it, okay. So in a say 2 hours, 3 hours workshop, we cannot do all these things, okay. But you can just simulate this thing, as if you are into a real environment, but in a classroom or in a uh, closed environment. We try to do this, debate it, and then come up with some kind of a prototype, making it using card box, with some card box and other stuff. Okay, and then the output is that the team presents their idea. Okay, so then we come to the last part of the slide. Okay, which is about the benefits of differentiated products. Okay, so increased market share. Maybe these were the problems that we were talking about, the saturation in the market and other things. Now see, we are going through that challenges that we talked about. Then we said that there is a need of product differentiation. How do we do product differentiation? Okay, go and apply design thinking. Okay, with design thinking, the company or the team has come up with something which is better and not incrementally better, but significantly better than its predecessor. Okay. Now this product goes to the market, right? What it creates for your for your business, okay, is there is a real value, there's a perceived value, it has improved significantly, and obviously customers are buying more about this product, right? And that is how you start increasing the market share. You don't remain very satisfied because competition is going to catch up. Okay, so you have to continuously do this. Okay, so at the same time, since we have been able to create that product differentiation, okay, the brand is seen as more innovative. Okay, customers are willing to go with this kind of a brand because they are coming up with new things which are improving the customer experience. Third is the pricing power. Okay, now that you are saying that I can do an energy saving, okay, with this pump, okay, is the customer willing to pay more for this? Obviously, okay, more, not more than their savings, but say for example, we have saved 100 rupees, okay, of their energy cost, right? and we are asking them to pay 50 rupees more on that product, right? So you have a better pricing power now, okay? And obviously, as I said, that now your brand reputation improved, the expectation, the unmet need of the customer, or during the empathize phase, we found out through the survey, okay? These are the concerns the customer has, all right? So we improve by making that changes, okay? We are improving the customer satisfaction and loyalty. Just for an example, modular pump design for flexible configuration, okay? So that was like something that the competition was not providing. It's flexible and you have a modular pump design. You just take it in a small, um, say a suitcase or briefcase, and then install it in the site, right? So that flexibility and all those things. Just to give you an example. So you see that how we are circling back into the product differentiation, their need, and how with this design thinking approach, okay, we are achieving it, and then handing it to back to the business and seeing all these benefits that the organization can get. But one very important thing here is patience, okay? These things takes time, okay? And that is why it has to be very important to understand that not every company is able to implement it, okay? Because when we talk about time, time is cost, right? If you involve a team who is doing this design thinking, that's a big cost, okay? But that's where a GE or Grundfos is going ahead of their competitors because they're able to do all these things. We have to also understand it that it is not like anybody can after this can say, okay, why we don't do design thinking? Let's all go and do design thinking. But it takes a lot of stages. It is not that you do a workshop and tomorrow you are having a enriched product, right, or enhanced product. But definitely that the investment pays off, and pays off in a very handsome way. Okay. So this is, let me, I think we have come to the last slide, okay, which is always a good feeling for participants to see the conclusion slide. So product differentiation and design thinking are critical for thriving in today's manufacturing landscape. Okay. I think I have driven this point enough. Okay. And by aligning innovation with customer needs, manufacturer can enhance business outcome. Okay. So both the things are there. Okay. It is not innovation in isolation. Okay. Innovation which is geared towards customer needs. Okay. So the suggestion is that whether you are a practitioner or whether you are teaching your students about this, or whether you are participating in some industrial activity, keep it in mind that how design thinking is having the potential to create that differentiation. Okay. And you can now reflect on this. There's a lot of material on design thinking on the internet that will interest you, excite you, and learn more about it. But this was just, I would say, a short introduction about design thinking and its relationship with product differentiation. Okay. I think I was not sure whether it is 1.5 hours or 1 hour, but I am somewhere in between. Okay. So I am done, sir.
Yes, sir. Thank you so much.
Yes,
Yeah.
thank you, sir. Thank you very much for your session.
Fine.
I request if there are any questions, they can ask. So the presentation was very well organized and engaging. I'm confident that participants have gained valuable knowledge and fresh ideas from your talk.
I see a question. Let me read it out. When we think of product differentiation for a specific group of customers, is it cost effective for the business? Because the number of customers is very small and systems set up for this differentiation no longer useful, perhaps. See, this is a very fundamental question. Okay. because it is not that you do business or you create product for everyone. Okay, few companies can do. Say Google can do a product which is for everyone. Okay, whether it is a small chai shop to the large enterprise, but not for every company it is possible, right? So you have to pick the battle. Okay, you have to select. Okay, as a organization that I want to create product. First, you have to have a product. Okay, to create a product differentiation. So let's say that now we are into the space of say creating pumps. Okay, now you will say that okay, there are whom do I compete with? Okay, there are larger manufacturers, there are smaller manufacturers, there are companies who are catering to oil and gas. No, there are companies who are catering to pharmacy, pharmaceutical, right? So you have to identify, okay, and then look at that is there some segment which is still attractive, okay, but is not considered in your so-called the scope of business, okay? And that's where the handshaking happens between the business and the product team. Okay, that should be considered, because as a product organization we may think, oh, why not, let's add some more bells and whistles to the product, right? But adding to that is a cost. The input cost can go up, whether we will be able to realize it into the profit in the in the future, right? So this is a very, very fundamental question to bring up. You cannot say that no, just for the sake of product differentiation, let's get charged up and start doing product differentiation. No, it has to be with a justification. Okay. For example, if you say that this segment is large enough, okay, today they are not willing to pay $1, okay, but the volume is so high that no, even I charge $1 per customer, I will make a high volume in terms of revenue. These are all very fundamental question to discuss. But yes, after you have decided as a group, then you should move ahead and see whether with design thinking, what kind of differentiation can be achieved.
Thank
Yes,
you,
sir.
sir, for that detailed explanation.
Yeah,
So Joshi sir, have you cleared your doubt? I think again there is a question from sir.
yeah. Is there any strategy or a procedure prior to going out of? Yes, yeah. Um, the strategy is very, very clear. Okay, because you do not start with a product differentiation, as I said. Okay, you start with what is the problem at hand, right? Remember, if you see I was consider only challenges in manufacturing. So these are, when you talk or when you are in the, uh, maybe in your, inside the boardroom that the discussion is happening, okay? Or outside when you are meeting customers, right? So you can see whether these are the challenges that the customer are facing, right? So this will be the point from where we will decide to create that product differentiation. It is not like product differentiation is not necessary. Say, for example, let's say you are into a business, okay? Say when Paytm started, right? The Paytm Karo moment, right? So there was nobody there, neither Google Pay, nothing, right? So Paytm was not pressured, right, to how to penetrate the UPI thing, okay? So if they had discussed at that time, market saturation, absolutely not, okay? Price war, there was nothing, price war, right? But later on, what they had to see is that, remember Paytm, when they came, there was no UPI, okay? So they were actually charging the customer, putting a money in their wallet, okay? So I put 100 rupees and then I spend 5 rupees, 10 rupees, 15 rupees, okay? And on that 100 rupees, they were making an interest, okay? Say 1% interest, and they were working like a bank, okay? But what happened is that there was no market saturation, there was no player like that. As soon as Government of India opened the UPI, okay, and there was no charges that the platform will make, right? So there was an immense pressure to innovate, right? Create that product differentiation, okay? And that led to one thing to another, and then this forayed into e-commerce and other things. Okay. So coming back to your question, yes, there's I would not say there's a procedure. There is a clear-cut need. Okay, which either your customers will tell or your business team will tell that now we have to, hey, product team, something has to be improved. Okay, we cannot stay in this, otherwise we'll lose the market share. Okay.
Yes, sir. So, Joshi sir, is there any clarification required? Yeah.
Yeah,
I
yeah.
think
Thank you very much.
the doubt is clear. Anyone else?
So I think we
Okay,
can then end
ma'am,
this session,
continue.
right?
Ranjani,
Yes,
ma'am.
sir. Thank you very much, Mr. Chatterjee, sir, for an engaging and highly practical sessions. Your perspectives on digital transformation and Industry 4.0 have added immense value to our FDP. With this, we conclude day 1 of ATAL Online FDP. For the attendance, the feedback link is now shared in the chat. Please complete it. And on behalf of Ashok Ramane Group of Institutions, on behalf of our campus director, our director ma'am, and all the entire organizing team, the coordinators, Dr. Mrs. S.S. Patil ma'am, co-coordinator, Dr. C.R. Dungursane sir, I thank our esteemed speakers, all the participants for your time and active engagement. Have a wonderful evening, and let's meet tomorrow with another 2 power pack sessions. Thank you so much.
Thank you.
Thank you very much, sir.
Thank you, sir.
Thank you all.
Thank you very much.
Yes. So here we end with the today's sessions, both the sessions. I will provide you the feedback link for the first day on WhatsApp for today only. And from tomorrow onwards, we will provide in the chat box of the Google Meet. Okay. So thank you all. Thank you again.